Hey everybody, this is Larry. This is me doing virtual contest 473. Hit the like button and subscribe button, join me on Discord. Let me know what you think about today's prompt or today's contest. I got my notebook ready, my pencil ready. Hopefully I actually, got my brain ready. And we will go. Alright. Am I ready? Yeah, let's go. Alright, let's go. Go. Alright. Remove 0. Okay, it's positive. Okay, that's the part that I was trying to find. Why my keyboard's weird? Something like this. If there's no 0, it should be fine. Yep. Alright. Alternating sum of squares. Rearrange any order. This is just greedy, right? Oh, but that's negative. Negative doesn't really matter, so it's just greedy, right? Yeah, okay. Okay, yeah. Something like that. Right? I don't know why my setup is a little weird. Alright. So basically, if it is even, or if n is even, then we just sum up the second half. Minus sum of the first half, right? I guess it should be a little bit sloppy. Otherwise, then we have an extra addition. So 5, we started 2. So I guess this is still right? Oops. We don't have off by 1, maybe? 12, 16. Alright, anything weird? Hopefully not. Okay, not that bad. Alright, integer capacity. Is this n is big, no n square. Number of stable subarrays. Alright, let's see what stable means. At least 3 first and last. Okay, so it's a subarray problem, Larry, not a subsequence problem. First and last element of the array are each equal to the sum of the element. Okay. So that means that they have to be the same, and then the sum of the middle has to be. I mean, I guess it's just it. Well, I don't know if this is it, but we definitely need prefix sum. I mean, the way that we could do it could be n squared, so I have to be a little bit careful. Oh, I see. Alright, because if the number is x, if the current number is x, then I mean, yeah, okay, this is maybe actually one of those drawing problems. So if the current number is x, that means that the prefix, the sum of the prefix I don't know, some t, I guess you don't really know. But that means that we want this is equal to x, and then this is equal to x, right? How does that work? That means that if we have x, we're trying to find t minus 2x. But it has to also be the case where I don't know that I get it. Well, I don't know if I get in n squared time or a lot more than or faster than n squared time, right? I'm missing something. Because there could be multiple of these, right? How do you check all of them? So do you have to look at all the other previous trees? No. But okay, so current number is x. You want to, so there's actually another equation here, right? You want the other stuff such that okay, maybe I got wait, yeah, okay, so the type prefix is some t minus, so the current prefix is what does that mean? Okay, so this is 27 because it's this times 3, but if you have a 1 in before, then it's going to be look for the 9, you look for 9 times 3. Okay. I mean, that part is easy, but I don't know how you would, because you have to still go through it, right? You don't, there's no greedy or anything. Am I confusing this? Okay, so there could be a lot of these, right? Am I missing something dumb? Because you can have negative numbers, that's the key part. If you cannot have negative numbers, then maybe that's a little bit easier. Actually, if you can't have negative numbers, it's trivial. But if we can have negative numbers. What does that mean? I think this part is also you have to do special cases with zeros. So do you search for t minus 2x? Oh, do you also hash? Because it has to be the n. Okay, I see. Because you also have to hash the number. Okay. Maybe. We'll see. Okay, maybe. I see. Maybe I should have thought of that. Because it is identical. I see. So something like this. I guess this is fine, maybe. I don't know. Because you can never have the entire... Oh, well, you can, but that's not what we're going to search for. We're searching for the first element, not the element including the first element. So, okay. Right, so then now we actually do look up... do we even need to store this? Actually, maybe not. Maybe it doesn't even matter because we're just doing count, right? So then now we want... There's some weird thing with zeros. We might have to handle zeros different. I have to handle zeros differently. Or maybe just use like a queue of 2 items or something. All right, let's. I think actually this would catch it, but so let's just ignore it for now, and then we write count. It's going to return minus x times 2 x. Right. Okay. Let's see if that works without that one. Or like the first number should give. Huh? Oh. Yeah. Okay. Whatever. It doesn't matter. Shouldn't matter. 3 is wrong because there's only 1, so I think we'd overcount this. But 2 for this is good, so that means that we're listening. Maybe we could just right. So 3 numbers, right? This is so dumb. Nope. Something like that, maybe. 2011. All right, let's go. Am I confident? I'm trying to think a little bit before I submit. I think it's the right-ish idea. I probably should test more, but I don't know if there are any good tests. So those are both just ones, right? All right, whatever. YOLO submit. Okay. Whew, how am I doing on time? I always check after Q3 because that's like usually a good parameter. People are much faster than me on the first whatever, but all right. All right, let's go Q4. Now it's time to wake up. Count distinct subarrays divisible by k and sorted. You have num sorted and a k subarray. Is this a subarray problem? Maybe. N is big, okay. So it's not DP, or maybe it still is. I don't know. Sum of the elements divisible by k. All right, fair enough. Distinct good subarray. What's a distinct good subarray? The sequences of are what? Subarrays are distinct. The sequence of values are what? Are distinct? Is that what they're trying to say? Okay, this is what I was trying to figure out the answer of. Yeah, okay, because yeah, okay. That's a little bit weird, actually. Maybe not. I don't know. Because this is the case that I was trying to get them to figure out. Okay. So divisible by k. K can be anything. Nums I can be anything. Is it a prefix? Yes. But the distinctness is kind of weird. What am I doing with the distinctness? Can I just write the non-distinct version first? It's non-distinct. Actually, this is like. This is literally like Q3 with non-distinct, right? So we have to think about this. I don't know if this is worth doing, honestly, but I just want to at least make sure my idea is reasonable. something like this, I think, right? And this is not going to be right because we don't care about distinctness. I just want to make sure we it is what I expect, right? Is this right? No, this is wrong even for that. So, oh no, that's just because I forgot that in this particular, this problem is different than Q3 because of that reason. Yeah, because that one, well, we don't have to describe it. Let's focus on solving this for now, but it is different for that reason. So, okay, so this is what I knew, but this part is a little bit awkward. How do I know that this is not distinct, or this should be distinct? And this could be n squared, so we can't really store all of them, because even just here, we could have k is equal to 2, and if we try to store all of them in a set or something, then it's going to be n squared space, which is going to be too slow, right? So then how do you do it? Oh, it's sorted. It's sorted. Actually, I mean, I did read that, but that's interesting. So sorted, what does that mean? Sorted means that you cannot duplicate it unless all the numbers are exactly the same. So if the subarray if it's sorted, it also means that the length is unique, because well, we just have to hash on the thing, because there's no the size is unique for a certain sum, but not for a certain sum mod k. So I have to be careful here. Okay. But it also means that so for the size and the divisor or something like that, it should so we should be able to identify then, because it's sorted by the first number, right? Maybe? Or the last number, maybe? Is that true? Yes. How do you dedupe in a good, or how do you collect that in a good way? Is that going to be n squared in the worst case? Because that's just the size of the thing. So you can't store even just one number, because there's at least an n squared possible subarrays. For example, they're all ones and k is equal to 1. Okay, but we made some observations. So how would I dedupe this? Current matters. Current matters, maybe. Maybe we have to subtract out something. So it's the current thing. No, I mean, yes, but something like you could have some, you have to be careful, because you can have something like, I don't know, for k is equal to 2, you have like 2, 2, 4, 4, 4, 4, 4, something like that. And you look at just like in the theory sliding window, but something like this, they're all distinct. So they're always going to be distinct, minus the ones where it is the same numbers. I guess that's the only thing in which. So can we do? So okay, so maybe we could do this and then subtract them out later. Can I do that? How would I do that? How would you subtract out the duplicates? The dupes all have to be the same because it is in sorted order. Can I figure out for each number how many dupes it may have? So for x, goes up to 10 to the 9 though, so okay. What does that mean? Or how, what is the practice? Does that even work? So this is 5. 5 we subtract out, we subtract out 1, 2, 3, 4. So we have 3 pairs. And we have okay. Okay, so what does this mean, right? Let's actually look at this in more detail. Oh, people count it quickly though, right? I mean, even with cheating, it's still fast. Maybe I'm just missing something obvious. So then now, how would I think about this, right? So let's just say I have 6 2s. So what is that? Or how do I say it? So 12 and 6. So the GCD is 2 or 6. Does that help? Does that even help? Like, what if this is 14, right? I mean, there's still, that doesn't mean anything, the GCD. If you have 14, and you want to get 6. It's more like it should be the GCD of 2 and 6. That means that for every 3, we 3, well, it's going to be every 3, and also every 6, and then every 9, and so forth, right? So multiple of 3s, and then do we do like inclusion, exclusion? It seems like ridiculously hard. Am I like going down the right path? Right, because every 3, there, let's just say we have 7 2s, then there are 5 of these, right? Every 6 we have 2, and then 9 we have, well, none. So then you have this sequence where it is I mean, it's doable. It's just weird. Really hard. Okay, so let's say we have 5 5 5 and something like k is equal to 7, right? well, let's say we have a lot of 5s. Doesn't really matter, right? Because we have okay, except we have 8 5s. We have 5 and 7. The GCD is 1. That means that they're relatively prime. That means that for every 7 we have 1. So that means that for this we have 2. Right? For every 14 it is 0. ... Right? So we can do this math, and I guess we can just calculate the math to make it go a little bit faster. Because this depends on k. So how do I sum this? I say there's 8 of these, right? So f of 8 . Also, something is weird because this GCD is 3. That's why we did 3. This GCD is 1, which means that I guess you get the LCM from this. So GCD, the LCM is 6. So the LCM is 6. Then you have 3. LCM is 35. So that's why this is 7, right? Okay. But and then now, so you have 8 where the, you want it for every 7. Let's say, let's just have a big number for a second. So we have 100. What would that give us? And for every 7, this is going to be just 100 minus 7 plus 1. And then 14, it is going to be 100 minus 14 plus 1. 21, right? So then this is just equal to so there's going to be 100 divided by 7 rows of these, more or less. Maybe I'm off by 1. And then for each row, so R is equal to this, then R is equal to 100 or rather the total sub. Do I want the plus 1? I want to actually not include the plus 1 because the plus 1 is the count, but we keep one of them, so we don't subtract them. So it's going to be this sequence, and then now it's just the summation of 100 times R minus this thing, which is going to be 7 times 1 plus 2 plus 3 plus ... all the way to R, which is going to be equal to minus 7 times something like this, right? Too lazy to get the parents right, but you get the idea. Is that right? All right, let's try it. I mean, what else am I doing? This is assuming that the uniqueness thing is true, right? Time to reclaim that space for now. Okay, so maybe we're off by 1 here. We have to see, but we can test this. It's not that bad. Go to okay. So LCM for key values in f of items. So then we have LCM of k. Oh, this is bad. The two I named them both k's. I don't know, x. Let's just say k and x. So L is equal to this, and maybe the thing that we care about, t, is equal to the LCM divided by x, right? And then now for every t, so then we have Okay, so R is equal to V divided by I was trying to find where the votes come from, but actually this is just T. And then, man, I keep on naming things the same way, but alright, fine. But count, we just subtract by the value times R minus 7 times, oh, not 7, oh, why would I be 7? What is the 7? It's T times, let's put this in parentheses, times, is it R? R times R plus 1 divided by 2, and then we should be okay. It's probably not, but I mean, in theory, okay, I mean, it works for this. Let's try for something like more ridiculous. Let's even try this one, right? I mean, I don't know the right answer, so maybe that doesn't really help that much. This is also 2. Oh, I guess so, because it's going to be 7 and 14, right? So that seems right, actually, for this. But we can also even add, like, something like that. Maybe that makes it interesting. Should be like 419. Oh yeah, I guess so. I don't know if this is right, honestly, but I'm gonna YOLO submit because it's gonna take me way too long to figure that out otherwise. But this is a ridiculous answer, right? I mean, we came up with it, but honest, I don't know. Maybe it is, maybe it's not. But that's a hard problem, for sure. I don't know how people got it in like 2 minutes, but I mean, props to them. I guess, I mean, I don't know, 20 minutes I feel like I'm happy with in terms of my solve time. I guess I could have been faster. People are so fast these days. And I was like brazing the first, I was brazing the first 2 problems, right? So it's not like, I don't know. All right, let's do a quick retro. Right. Okay, we moved. I mean, this one, yeah. I mean, I don't know. I clicked on 4 things, didn't I? What was the? Okay, whatever. So Q1 was fine. Q2. The reason why I'm so fast at this is because there was like a problem recently with this, right? Like, I mean, it wasn't the squares part, but the squares just makes the negative numbers even worthless. So, but I feel like we had a very similar problem with this. That's why I was able to get this so quickly. And technically, yeah. No, I mean, I think that's it. Yeah. Like, I don't remember it was a contest or the daily problem, but we had something very similar lately. Maybe even like either, like literally a week ago or 2 weeks ago. So that's why I was able to get this pretty quickly. Yeah, I mean, I think this one, I took a little bit more time to kind of think through all the edge cases, but I don't think it was that bad. It was, like, I probably could have been faster, but I don't think I was that. So, I mean, there were only a couple of possibilities that I was thinking of in terms of lookups, and I kind of went the wrong way twice. I mean, I'll explain it on the actual explanation video, but I went the wrong way twice. I mean, what I'm looking at is just my notebook that I actually drew for this problem. So yeah, I don't know. And then Q4. Oh yeah. I mean, we just solved Q4. I mean, I get it. I mean, I think there is this observation that you have to, but it's a little bit of a leapy one. And maybe it's one of those things that you get from experience. For hard proof, I'll probably try to do a hard proof later, but yeah, but I think that's basically the idea, is just trying to, I mean, that observation is kind of hard though. I don't know, everything has to be equal for it to be non-distinct. The phrasing is also a little bit bad, but and then this formula, hopefully, I mean, I kind of did this part very slowly, even during the live portion. I don't know if I would have been faster these days. Maybe if I wasn't doing a virtual and like I really want to speed up, maybe I could use my notebook to kind of go think through it a little bit more. But I feel like after making that observation about the distinctiveness, it's just one step at a time. I mean, and it did turn out that this was very helpful, actually, right? Like I kind of just wrote it on a whim just to kind of give me an idea, and it did give me an idea, and that I can just subtract the rest. I don't know. It's a little bit awkward though, for sure. Anyway, that is all I have for this one. That's all I have for this contest. I mean, not a terrible end, if you will, but definitely a little bit on the harder side for sure. Or I don't know if it's hard, but just like tricky for me. Is there like a dumber way to do Q4? No, I'm curious. I mean, even if this is no, I mean this is basically exactly what I do, right? So people are able to get that very fast. I mean, I know the top is probably ChatGPT, but like 8 minutes. TS Reaper is like a ridiculous person, and it took him 8 minutes. Like that's my benchmark for non-cheating, non-AI things. I mean, I wrote this part. IJ. I guess they did it with some sliding. Oh. Oh, I see. I mean, if he thinks this is fast enough, then it must be. But I was thinking about something along these lines. That's when I kind of drew this out, and I was like, can I get away with doing a for loop? And I wasn't sure that I could. Oh, I see. I see. I see. Okay, I see. Huh. Yeah, no, that makes sense. Actually, yeah, I overcome getting coming of this one. That's actually beautiful. Uh, I missed an observation because I was just like, okay, this could be 10 to the 9, right? So if you have 10 to the 9, you can't really like just do a for loop. But you actually can, because this is not the number that goes 10 to the 9. This is the count. This is the frequency, and the frequency can only be O of n. And we have n divided by 7, and you have basically the same analysis with prime of Sif. Is that true? Oh yeah. Is that true? What if k is always 1? Then you have LCM is I don't know. That's weird, actually. I mean, maybe maybe do something a little bit smarter. So he does it at the border. It gets the count, and then during the count, okay. Well, his loops are different actually than how I would imagine I write it. So actually, this is not the Ceph idea. This is the idea that basically you have to count. Yeah, okay, I see. So this is linear because okay, yeah. Okay, I'm a little bit wrong on this one. Maybe I'll how do I do want to remember this idea though. That's why I'm trying to okay. Yeah, because this is the idea. This is basically the same thing as you do in like 2 pointers, and basically length can only be O of n, and you just do a loop to length. So every item gets looped once, and as a result, and this is just the sum and where there's mod k. This is way. I mean, I think the reason why you want to do it that way is because you have to prove one fewer things, and as a result, it is just faster, right? Because then you don't have to come up with the formula like I did. Like I had to come up with this formula, which isn't that hard. I mean, just to be honest, just to be frank, right? But like if you save 5 minutes, that's 5 minutes, right? So yeah. All right, that's all I have for this video. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.